This one is basically, like I said the other day, it's pretty much the same stuff. It's just probably maybe a little more difficult. We probably will do one new topic later on that you may not have seen before, but it's just an expansion on foiling. Okay, so this one's going to it'll be kind of like those last four on your worksheet. So just kind of to get a little practice with a little bit complicated. We're going to ease into the complicated ones here and then move it on through. All right. So, the first one. Anytime, what's up, bud?
Oh, it's in your mailbox.
Perfect, thank you. Anytime you see multiple multiplications, all right, everybody cool with that? Those words? If you see multiple multiplications going on, so we have parentheses, parentheses, parentheses. What I do is I just multiply everything together. I don't even worry myself with the negative exponents yet, because what hopefully happens is they'll work themselves out. Hopefully it just takes care of itself eventually, all right? So I go through, I do my numbers. So 2 times 3 gives me 6. All right, then let's do our a. So a to the negative second times a to the third. What do you do with these exponents? Since they're on the same level, you add. So it's negative 2 plus 3? 1. A to the first, or just a. The b tags along, and the c tags along, since they're the only ones that happen each time. See that? 1b, 1c. Okay. Is that it? What's still wrong? What's not simplified? That negative exponent. Okay. So it's got to go denominator. And when you write that in the denominator, it turns positive, and make sure you write it. Oh, come on. Underneath the other stuff, okay? All right, underneath your original term. Just move it down below it. So this one we have q squared r to the fourth over q to the seventh r cubed. There's really two lines of thinking about this. The line of thinking I'm going to go with first is applying my rule. All right, and the rule says whenever you have the same bases and you have them over top of each other, you do what with the exponents? You subtract them, right? If you're dividing the bases, you subtract the exponents. And we've always done top minus bottom. So that's what I'm going to set up next. Okay, so I'm going to go top minus bottom. So my q's are going to become q squared, or 2 minus 7. And my r is going to become r, 4 minus 3. Okay. So q 2 minus 7 gives you what? Negative 5. 4 minus 3 gives you 1. So r to the first. Almost done, but what do you have to do? Got to move the q's to the denominator. Okay, so then your final is r over q to the fifth. And you're done. Okay. One line of thinking for it. The other way to think about this is a little more complicated, okay, but not too bad. Since this is negative, if this is negative and I move it down, that makes it what? Positive, right? Okay. What if it's positive here and I move it up? No. It goes negative, right? From here to here it went positive. From here to here it would go negative. Okay? So up here, instead of worrying about this negative exponent right here, I could just move these two q's down, make them negative, and do 7 minus 2. Okay? That's a little more complicated. I think I'd rather see you guys just stick with this rule and then deal with it after the fact. Okay? EJ?
So the fraction bar, you treat it like an equal sign. So if you move it up, you do the opposite. Like.
Yeah. Okay. Yeah. I see what you're saying. Yeah. You just change the sign of it. Yeah. Yeah. Or if you move it down even. Okay. Everybody good? So this one we have negative 2a to the fourth all over b squared. Okay. The cube on the fraction means you're going to cube the top and the bottom. You're going to cube both things, the top and bottom. So I'm going to write that out first. Let's change the color, brighten it up a little bit. There we go. Okay, now when I cube the bottom, what's that going to become? B to the 6, right? 2 times 3 gives you 6. So B to the 6th. When I cube the top, okay, now how many terms, how many monomials are in the top? How many terms? How many things? There's 2. -2 and a to the 4th. Okay? There's 2 things. When you cube that top, each one of those needs to be cubed. Okay? So now we're going to make it set up like this. -2 cubed a to the 4th cubed. Now you simplify that. So what's -2 times -2 times -2? -8. A to the 4th to the 3rd? A to the 12th over B to the 6th. Okay, what do you do with this -8? Are you sure? Do you move that -8 down? Yeah? Any no's? No. No. Why don't you move it down?
Because the exponent isn't positive.
Because
the exponent isn't negative.
Because the exponent isn't negative. Very good. The exponent isn't negative. The number's negative. That's okay. The exponent is what can't be negative. So what's the exponent on 8 now? It's 8 to the first. Last time I checked, 1 is positive. It stays where it is, okay? It's only when the exponent is negative that you move it, all right? Make sense? So that's a final answer right there.
So if it's got a power to it, if you move it.
If it's got negative power.
It's a negative power.
Negative power. Next.
So like, what about it was a -8 and -12? Do we just move them both to the bottom?
Well, if this was a -8 and if this was an 8 to the -12, then you would just move the A. Okay? So side problem, if it was like -8, A to the -12 over B to the 6th, you'd have to clean that part up and then make that -8 over A to the 12th, B to the 6th. Okay? You don't move. The only time you'll ever move a coefficient or a number like that is if it's got a negative exponent to it, which will rarely happen. All right?
So do you change both of the signs and just have the negative? So
Just the one on the A, just the A's exponent. Okay? Because you treat each one individually, right? It's not like you got to move the whole group. Okay? The -8 can stay. The A has to move. All right? Because if it was something like, and then let's throw a C in there. Let's make it C squared. The A has to move, but the -8 and that C, they would stay up top.
now I was talking about like, what about that -8 had a power?
Where at? Like this one right here. You got to move that one. Yeah. Okay. Everybody good? Okay. The book. Okay, the book wants to refresh some few things with you guys, as far as like getting into like terms. So we're going to do that real quick. Here, what do? You just do like terms. Okay, we're going to be doing like terms again a lot. So that's why this problem's here. So they want to refresh it. So like terms mean you have same what? You have 2 things that have to be the same. The term itself, and then specifically the exponent. The same base attached to it, the same exponent. All right, so x squared. All right, x cubed. Okay, so up here, 6x squared, -4x squared, -7x, 9x, 8, -5. Notice the plus which just means add, okay? These you don't FOIL because they're not touching. So what's 6 minus 4? 2. And it's squared. All right. Negative 7 plus 9 gives you 2. And you put x with it. And then 8 minus 5 gives you 3. So 2x squared plus 2x minus 3. Okay, for this one, what do you have to make sure you do first before you do anything else? Well, here, what's different about this problem than the last one? You're subtracting, which means we have to do what with this guy? Distribute it through. That way we make sure we change these signs. So 4x squared minus just the 1. Right? Because we're taking that guy, and then from it we're going to subtract all of these. So minus 2x squared minus 3x, and then minus the negative 1 becomes plus 1. Okay, so just change the signs in the second set. All right. Now go through and do like terms.
So, if you're subtracting like terms, you have to make one side negative all the time.
Yeah, if it's set up like this and you have a minus in the middle, distribute it through, change these signs.
Okay.
Then you just combine them like you would.
And so it's going to be the right.
Yes. Whoops. Okay, so 4 minus 2 gives you 2. X squared minus 8x plus 7. So 3 times 2 gives you 6. X times x squared gives you? Good. Minus 3 times 4? 12x plus 18x. Child's play? Yeah, pretty good, right? Pretty basic, pretty easy. Oh! 4/3 x squared times the quantity 6x squared plus 9x minus 12.
So like we can add one more of what, you know. So 6 is 2. So 6 is 2. So 6, 7, 8, and then 9 is 3, and 12 is 4.
When you distribute, the operation you're doing when you distribute is what? Multiplication, okay? So you have to remember how to multiply fractions. Alright, when you multiply fractions, you multiply the tops together, you multiply the bottoms together, right? Okay, so all of those terms inside the parentheses are whole numbers, so you can write them all over 1. Okay? Now, when you go through and do that multiplication, think about it. You're going to multiply 4 and 6 to give you what? 24. 3 times 1 gives you 3. And 24 over 3 gives you 8. Okay? The other way, like Stovey was saying, you could just divide this, reduce this 3 into this 6, make it 2, and then 2 times 4 gives you 8. Either way, whichever way you think about it best. Or you can do what Pusa did and use your calculator. That's totally fine too. All right. X squared times x squared gives you x to the 4th. Minus same process here then. 3 goes into 9 3 times, and 3 times 4 gives you 12. So 12 x to the 3rd. This 3 goes into 12 4 times, and 4 times 4 gives you, it's a plus here, ain't it? There we go. Minus 16, and then the original x squared from ahead. Okay, so you're going to have, fractions are going to happen more often as we work through the rest of the year. Okay, so we have to start working with, the sooner we start working with them, the better off everybody's going to feel about them. So we're going to start sprinkling them in more and more. Alright, because next chapter there's going to be a full section of it. Okay, so we really want to make sure that we got them, we're comfortable with them by then. Alright? Any questions? Okay, before we move to the next slide, I'm just going to throw something up here. You don't have to do it. I'm just going to ask you how you do it. So x plus 2 x minus 3. Here you would do what? You'd FOIL, right? You would FOIL. We're going to take foiling and we're going to apply it to this. All right, now what's the difference between what's on the board and what I just wrote? There's an extra term, okay? Foiling is an extension of distributing, okay? Distributing is like the general term, okay? Like, you know, fingers, general term, right? Then you get specific, thumb, index, middle, ring, pinky. Distributing is the general term. Foiling is a specific case for when you have two binomials. All right. Here we have a binomial and a trinomial. So the way we multiply these is not foiling per se, but we're going to take foiling's concepts and do the exact same thing. We're just going to do it an extra 2 times. Okay? I call it triple double distribute. Okay? Triple doubles, yeah. Right, Nash? So what we're going to do is this. We're going to take x squared. And just to show all the work, I'm going to take x squared and I'm going to multiply it by x plus 2. Okay? And then I'm going to take 4x and multiply it by x plus 2. And then I'm going to take negative 6 and multiply it by x plus 2. Okay? Turn it into 3 smaller distribute problems. 1 for each term in my trinomial. Okay? So x, the first term of my trinomial, times my binomial. Second term times my binomial. Third term times my binomial. Alright? Make it 3 smaller distribute problems. So now each time you're going to distribute those through. Okay, so x cubed plus 2x squared. I'm going to stay true with my colors for now, so that you guys know where everything comes from. Plus 4x squared plus 8x minus 6x minus 12. All 3 distributes. Alright. And now you see that you have what? Like terms. So combine them. Alright. So you have x cubed all alone. You have the x squared, 2x squared, and the 4x squared to give you 6x squared. 8x minus 6x gives you 2x. And then the minus 12 there at the end.